Right. First question that we have is a person on skis. Now, actually, I combined all these papers of 2024 June, 2024 October, and 2025 Jan. Without missing any question, I added all the questions according to the lessons. So it's easy for all of us to understand how the trend goes on, right? So we will move on like this. So we'll see, as we see, if we see a question newly, how to think and all those things we will discuss. A person's key slide down a slope. Slope is at an initial angle of 14 degrees to the horizontal. The initial speed of the person is 7.1 meters per second as shown. The resistive force acting on the person are negligible. Calculate the speed of the person after moving 15 meters down the slope. So this question can be done in two ways, either the speed way or either the energy way. Generally, if a question has kind of like a slope like this, then you are not allowed to use the speed equations. I think in the tute, I explained you that one. You are not allowed to use equations because since the direction of motion is changing, the component of weight that accelerates the person is different. Therefore, acceleration would be different, not constant. Since acceleration is not constant, we can't use equations of motion. But this is a question where the slant or the slope is the same. So always, when we have the weight, this angle we all know it's equal to 14 degrees. Then the component of weight along the direction of the motion will be W sine 14 and it will be always constant. It won't vary. Because of that reason, acceleration also will not vary. Hence, we can use equations of motion. So I told you the reason also. Now, as usual, we'll summarize what they have given. Initial speed, the letter is U. The resistive forces acting on the person are negligible, so we don't have any resistive forces away. Then we should find the angle initial speed is given. Resistive forces are negligible. Calculate the speed of the person after moving 15 meters down the slope. Right? So that is the idea. 15 meters down the slope. So that means this person is moving 15 meters down the slope. That's what the question says. So we will try to use down the slope F equals ma. Why do we need to find it? Because we want to know what is the person's acceleration. So as I told, it's the component of force along the direction of the acceleration is mg sine 14. This is equal to mass of the person is still m and the acceleration. So we figure out that the acceleration is g sine 14. I think everybody understood that. Now the problem is it's not under free fall. Under free fall means what? If any object only has the downward weight force in the direction of the acceleration. So I told two conditions. Only force acting on the object should be, and the acceleration also should be in the direction of the weight. Then we can say it's equal to gravitational acceleration. In here, we could not use it because acceleration is not happening in the direction of the weight. Therefore, we have to figure out what is the acceleration. Now we can use what v square equal u square plus 2as. V square, u square 7.1 square. 2, acceleration is 9.81 sine 14. And the distance that they tell is along it will be 15. Then you can find the speed. That is by taking the square root of right hand side. So you will be getting an answer which is rounding off to 11.0 meters per second. That is one method of doing the question. Suppose someone is like doesn't like in that way. If someone doesn't like that way, what we can do is we can use the kinetic energy and gravitational potential energy equation. That means we can consider A and B. So we know initially at A, the person has a velocity, so person has a kinetic energy, plus person is above the ground, so the person also have a GPE. So the GPE at A plus the kinetic energy at A will be simply equal to only kinetic energy at B, because if we consider this as the ground level, there the GPE would be equal to 0. GPE at A can be found by, this height can be found by, this is the hypotenuse, 15 sine 14. We can find like that. Then M, which we don't know, G 9.81, and we have what 15 sine 14 plus mgh plus kinetic energy half m 7.1 square equals kinetic energy at B will be half m final velocity square. So what happens? M cancels off, and you will be capable of figuring out the value of B. So possible, isn't it? That would also give us the same answer. This equation can be used when we know frictional forces, work done against friction, when they are not available. Okay, I think everybody understood that. Now we will move on to the next question. The second question, that is, two cars A and B are racing along a track. Car A has a constant velocity and car A has a constant velocity of 93. At a particular instant, car A is 9 meters ahead of car B. That is the instant that they have already drawn us. At this instant, car B has a velocity of also 93, same velocity. Car B is accelerating with a constant acceleration of 14 meters per second. Show that car A and car B are side by side after a time of about 1.1 second. Okay. Side by side in the sense, children, two situations must be there. One thing is this car A and this car B must be at the same place, same time. So this car should travel. Do we know the distance that this car has traveled? No. So the distance that this car has traveled, let's take it like S. Then the distance that this car should travel at this time will be, it is equal to what? S plus 9. That's how we have to think. Now, you can understand how peacefully, how easily we can think of it, isn't it? Then, okay. Now, after a particular time, 3 seconds, they both are in the same distance, same place. Let's say like that. That means this one has to travel S, this one has to travel S plus 9 at t equal t seconds. So we have to figure out the time. Now we will make equations to the distance traveled. For car A, it's easy to write an equation because it's simply S equals UT, y half AT squared plus becomes part becomes 0. So what I have found by looking at your answers and all those things is many students are not very carelessly taking the acceleration. Sometimes some students horizontal motion they take 9.81 in projectiles. Those things have to be very carefully addressed. Then when it comes to car B, there is an acceleration. So the equation that we can use is S equal ut plus half at square. Now we'll substitute S. Car A has an S of S actually. It has only traveled S. The initial velocity is 93 and the time it takes, which we have already assumed that it's t. Car B has to travel a distance of S plus 9 within that time t seconds, starting with 93 meters per second and having an acceleration of 14 meters per second squared. And we have t squared. Then we have two equations, so simultaneous. We have to figure out the time, so I'll replace this s by this sy because I have considered the same s, isn't it? Here to here also s, here to here also s. So s represents the same magnitude. Therefore, I can replace this with 93t plus 9 will be equal to 93t plus 7 and t square. 2 and 14 makes it 7. Then we got that. Then from this one, we can see 93 and 93 are cancelling off. So it's easy for us. It tells us that 9 will be equal to 7t squared. So from that, we would be getting t equals square root of 9 over 7, which is equal to 1.13 seconds. So I hope you will okay with the argument we make. Right. So check and see whether you all are okay with that. If any doubts are there, tell me. Right. I hope everybody is okay. Then we'll move on to the next question. At the instant shown, car A is 100 meters from the finishing line. Deduce whether car A reaches the finish line before car B. So to do this question, best option is find. Now the previous question is over. Now I'll move on to the new situation. The new situation, we have to find who reaches the finishing line first. So in this situation, what we have to figure out is the velocities and all can't change. 93, 93, acceleration 14. This one has to travel 109. This one only have to travel only 100. Then this is under acceleration, meters per second square. This is under constant velocity, RA. So you can use S equal ut plus half at squared equation to find the time taken for car A. You can find this to find the time taken to find the time for the car B. How do you find the time? S. This car travels only a distance of what? 100 equal U 93 T TA. So TA you get 100 divided by 93. You would be getting an answer which is equal to 1.075 seconds. This one, you have to use S is 109, U is 93, T is have to find plus half, A is 14, and T is TB squared. This would lead us to a quadratic equation. So after going for the quadratic equation, I always like if you can show the method, the time does not permit. However, you can quickly get down the answer. But I always like if you are going for the quadratic equation. What is the quadratic equation to find the t? You have to rearrange this equation. That would be 7t squared plus 93tb. This 109 comes to the right hand side, minus 109 will be equal to 0. So from this question, this one, you would be getting a quadratic equation. After that, use minus b plus or minus square root b squared minus 2ac divide by 2a. From that, you will be able to find the value of tb, which is equal to 1.084 seconds. That means what is our conclusion? Our conclusion, don't forget to write the conclusion. Our conclusion is time for car A to reach the finishing line, that is lesser than the time for car B to reach the finishing line. So who reaches the finishing line first? Therefore, A reaches the finishing line first. So it's not this what we really like to see. So it's this. Therefore, car A reaches the finishing line first. Valid conclusion must be there in this kind of questions. Children, at any moment, if you figure any kind of doubt of what I'm telling, please tell me, okay? I'm trying my level best to give it in a more informative manner, right? Okay, now we'll see the next one. Right, this kind of questions are also now, I think this is the third that this kind of a question appeared. I'll teach the method to this one. A student climbed a meat roll. The story is there. Dropped the ball from rest near the top of the meat roll as shown. The strobe emits flashes of light. The time interval between the flashes is constant, right? So that means when the light source makes a flash, we see the object. Again, switches off. Again, after like 1 second, it would make another flash. So we see where the object is. That's how we manage this. The student photographed the falling ball using a strobe lighting. The ball can be seen at different heights in the photograph as shown. For each flash of light, the student determined the distance fallen by the ball. Okay. She took one photograph using a strobe app on a mobile phone. She took a second photograph using a laboratory strobe. The time interval between flashes was the same for strobe app and for the laboratory strobe. Each flash of light from the laboratory strobe has a smaller duration than flash from the mobile phone. Right. Each flash of light from the laboratory strobe has a smaller duration than each flash from the mobile phone. Then explain how the smaller duration of each flash from the laboratory strobe affected the uncertainty in the measurement of the distance fallen. Now just think, if the flashing time is too high, you would not see a perfect location, you would be seeing a dragged location. Why? Flashing time is too high. Then what about the uncertainty that you have in your measurement? That would be low. The reason, you can't locate easily where the object is. But if we quickly flash, we quickly send the light and switch it off, isn't it? Then what can we say? We would obtain a smaller image, smaller sphere, exactly which is equal to the size of the ball. So what can we say? Uncertainty would be less. So that's what they want. So you can understand, when when you we have to assume that you have a little bit of an idea about photography. So you see that when the aperture is on for a long time, that dragging images are seen rather than a very resoluted image. Okay, so here, then the idea is what? The idea is the image of the ball will be smaller. Therefore, uncertainty would be less. Uncertainty would be less. That is the main reason behind that. Then part B, it's not percentage answer. Percentage uncertainty will be obviously low, but it's actually what? The uncertainty. Then when we use what? When we use a laboratory straw, because the time duration is very small. Then part B, they are telling the student recorded the distance s fallen by the ball and corresponding values of the time t. Explain why graph of s against t square gives a straight line. So we have to go with the explanation of an equation and how we can tally it with a graph. So what is the equation that generally we use? You can remember in the first few days we learned about finding the gravitational field strength experiment. We use S equal to T plus half AT squared, and the other method was what? V square equal U square plus 2AS. But we can't use that equation as time is involved. That's how I thought of it. Then we have to say generally in marking schemes, generally all this time they have given a mark for telling you equal 0 meters per second as the ball starts from rest. Right? This marking scheme they have not allowed. They have not given a mark. Not allowed. They have not given a mark for this. But always it's a good practice to say what? As the ball starts to fall from rest, u equals 0. Then only it allows us to write what equation? S equal half. Ball falls freely. So A is equal to what? G. G T squared. Okay. Then still not enough. Then we have to write what? This is in the form of y equal mx. Write that. Okay. This is in the form of y equals mx. We'll write this statement. Okay. It's better to write underneath also, but we'll write this. And not enough. And I think you can remember with unit 3 work. And G is constant. Therefore, gradient, which is equal to half G, is a constant. Hence, graph is a straight line. And the other thing is, you all can see if they ask straight line passing through the origin, where would the third mark point will be? We can say C is equal to 0. What is C? That y equal mx plus C. C equals 0. Therefore, the graph doesn't have a y-intercept. You can tell like that. Then we'll move on to the next question. Determine the acceleration of free fall using the student's graph. So what you have to do is you have to determine the gradient. To determine the gradient, take some two good points from the graph. Good points in the sense the place where the graph cuts, goes along a line. It's always better to pick a point like that. So it depends on the person, depends on person to person. So I like to take this point, and other point I like to take 0, comma 0, not because I told that it passes through the origin, but because I can see that it passes through the origin. So I see that 10 squares gives 0 0.02, 1 square gives 0 0.002. I hope you can remember. Always better to check the scale. So this would be what? 0 0.042, the time. And the y value is, this is 0. 10 squares gives 0 0.1, 1 square gives 0 0.01, so this is 0.21. And the units, I confirm that they are the standard units, good practices. Then we will find the gradient. This minus 0, this minus 0. So half g is given by the gradient 0.21 divided by 0.042. Then g will be equal to 2 times 0.21 divided by 0.042. I just told you the method, but that is the most important thing. You would be getting an answer. Always don't forget to write the answer with the correct unit. Unit, without a unit, your answer is not valid. Then you would only get 1 mark for attempting to the gradient. Right. So always write the answer with a unit. Then the next thing, children, that is the graph shows how the displacement. The graph shows how the displacement of a racing car along a straight track varies with time. So always remember to check the axes. When it comes to displacement, earlier question was velocity. This question is displacement. Now think and see, what are the things that comes to our mind? Gradient gives us velocity. You can see the steepness, the slope, or the angle here is very small. But the angle here, that means in another way, the steepness is very large, isn't it? That means what has happened to the gradient or the steepness or the angle? It increased. That means the gradient increases. The gradient increase means the speed is also increasing. That is ideal. Okay, the student used the graph to calculate the velocity of the car at. When they use the word at, it becomes instantaneous velocity. Sorry. The student wrote velocity equal displacement divided by time. Displacement is 300, time is 15. That is actually the student has calculated the average velocity, not the velocity at 15. State why this value is incorrect. So we have to state why this value is incorrect. Calculate the correct velocity. So first of all, tell why it is incorrect. Because 20 meters per second is the average velocity. Therefore, it is incorrect. Then we'll try to calculate the correct velocity. How to calculate the correct velocity? Keep a ruler here. Draw a tangent to the graph exactly at 15. Take two faraway points from the graph that you have drawn. Then take y difference divided by x difference. You will be able to figure out an answer for this. Same as earlier, take the coordinates, find the gradient. Gradient is actually the velocity at 15 of the tangent. So what is the theory that we revise from this question? Tangent drawn to a curve at any point in a displacement time gives us the velocity. Then what if this is the velocity time graph? If this is the tangent and if we found the gradient of the tangent, you will be getting the acceleration at 15 seconds. That is the idea. Okay, right. Now we will see the next question. The gradient of the graph continues to increase as the car traveled along the track. That means the velocity is continuously increasing. But after 20 seconds, the rate of increase of gradient began to decrease after 20 seconds. So If they ask us to draw the graph, still the gradient, they're telling gradient are the rate of increase of the gradient. So we do not misunderstand. It's not gradient is decreasing. It's the rate at which the increase of gradient began to decrease. That is the idea. Now, that means it's supposed to go like this. Supposed to go like this. If it continues the trend, isn't it? But if it continues the trend, the graph is supposed to grow like this way. But they say the gradient did not increase as we expected. That means velocity did not increase as we expect. Which means why the velocity does not increase as we expect. Still the velocity is increasing. That means acceleration is still happening. But the acceleration is not increasing. That is the reason. Then what should happen? The acceleration should be decreasing. Still accelerating, children. Still the velocity is increasing. Still the curve is upward. It's not a curve like this. Then it's decelerating. Still it's going like this. Still they are telling the rate of increase of gradient is there. Still the gradient increases. But gradient increases means velocity increases. Isn't it? But it increases at a reducing rate. It means acceleration is decreasing. That is the idea we have to say. So as soon as I see gradient, the rate of increase of gradient, as soon as I see increase of gradient, the conclusion I made is what? Velocity is increasing. As soon as I see rate is decreasing, what is the idea I got? Acceleration is decreasing. Now we'll argue. Still the velocity is increasing, but acceleration is decreasing. Then the reason, of course, you can remember a little bit of a story of terminal velocity would help us, because you can remember when the velocity is increasing, the drag forces opposing the motion will also increase. Therefore, the resultant force will also decrease. Resultant force also will decrease. That is the idea. Now, those are some linear questions. Now, some projectile questions, just to remind you about the projectile motions. A child is playing a game. The child is trying to get stones to land inside an old tire floating on the water. Right. So as soon as I see this, what I realize is this has a, now, if we try to analyze all these things in a combined way, it's hard. We will analyze these things in an easy way. 6.3, I hope you can remember, away from 55, sine 55, towards 55, 6.3, cos 55. I think you can remember their names. This is the initial vertical component of the velocity. This is the initial horizontal component of the velocity. Then I think you can remember this horizontal component of the velocity remains constant under the assumption air resistance is not acting. I hope you can remember that vertical velocity, when the object is going up, the vertical velocity reduces. At the maximum height, the velocity will be 0. Then afterwards, it falls down. So while this vertical motion is happening, the horizontal motion is also happening. That's why the ball goes this way also. So we will not see it like this. We will see it like going up and down and going horizontal. That's the easiest way to do this question. Show that vertical component stone's initial velocity is this and horizontal. That's what we did. Q vertical 6.3 sine 55 meters per second. That will be equal to 5.2 meters per second. U horizontal, that will be equal to 6.3 cos 55, which is equal to 3.61 meters per second. 5.2 was okay, 5.16 was okay, 3.6 okay, 3.61 okay, anything more than that is also okay. Right. You can see that these are for 2 significant, these are 3 significant, so you can keep either 2 or more. That's better, not 1, okay? And the other thing is show that is there for 1 significant figure. Definitely your answer should be more than 1 significant figure. These are the advisors, okay? Then they are telling, show that the greatest height. As soon as you see the greatest height, I think children, you can understand that this is about what? The maximum height. That means vertical motion, isn't it? Not horizontal motion. Is about 3 meters. Reached by the stone. Greatest height above the surface of the water. So that also we have to be very careful. It's not the greatest height from the place where it was thrown. It's from the above the surface of the water. Don't worry about above the surface of the water. First of all, we see from the place where it was thrown, what is the greatest height it reaches. Now we'll summarize what we know. We know that when the object is going up or going down vertically, there is always a downward acceleration, which is equal to 9.81 meters per second squared. Initial velocities we have found 5.16, let's say. Whatever the answer that you are writing here, we'll take 5.16 meters per second. That is the initial vertical velocity. We also know that the final vertical velocity will be 0 meters per second because that is at the maximum height. I hope that is okay. They want us to find S. So what is not involved in this equation is T. So the only equation of motion, as I always say, the easiest way to select the equation is what? See what is not there. Then check what is the equation that we have without it. V square equals U square plus 2AS. So we will use that then. Thinking upward is positive. These are good practices. V square equals U square plus 2AS. I think you understood why I wrote like negative. That is because I thought upward is positive, but gravitational acceleration is downward. So I had to substitute it in negative way. Then you would be getting an S value. You can even take it from the calculator. No issue with that one. 1.36 meters. But children, we have to remember that we use this equation from here to here. So we got here to here, it's 1.36 meters. So what is the total distance from the surface of the water to the top? That is 1.25 plus 1.36. Which is equal to 2.61 meters. I hope everybody is okay with that. The inside of the tire is 0.8 meters in diameter and is 3.9 meters from the side of the water. That means we can go from 3.9 until 3.9 plus 0.8 is 4.7 meters. So if the horizontal displacement is between these two, it will land inside the tire. That is our target now. Now, children, they can, I'll tell that later. Now, in these kinds of questions, what is the best approach that we have? I think you all can remember that we can go for a time measurement. Then using that time measurement, we can find the horizontal displacement. We'll have a plan now. How do you find the time? You see, this is going up to a particular maximum height. And then it falls down to the ground. As I always tell, don't bother about the subsequent motion. Only bother about the start and the end. Therefore, if this is the start and this is the end, U will be at the start, V will be at the end. S will be from start to end. Now we'll summarize. What is S vertical? It is downward. So start is here, end is here. Arrow is pointing down from start to end. If the start is here and end is here, it would then be an upward displacement. I think all can understand that. So, children, that is fine. Then that would be equal to what? That would be equal to 1.25. 1.25 meters. Right. Then the next thing is we have an initial velocity that is at the start. What is that value? U vertical 6 point, we have figured it out, doesn't it? That is 5 point vertical velocities 5.16 meters per second. That is upward. Then gravitational acceleration, which is downward, 9.81 meters per second squared. Time is the one that I have to figure out. So the thing that I have to omit is final velocity. And I was concerned about the vertical direction. I will consider downward as positive, because most of the things are downward. And I will write S equals on the equation that does not contain the final velocity. S is 1.25. U is 5.0. If I write like that, I will be wrong, isn't it? Why? I took downward as positive. Upward is U. So it should be negative 5.16. Be very careful with that, children. Minus 5.16 plus half 9.81 and t square. Now you understood. I was almost going to go wrong. So in the exam, be very, very careful with those things. So writing the arrows would not take 4 minutes. Writing the correct equation with the correct positive direction would not take 4 minutes. It allows us to find the correct direction, positive, negative. So it all plays the price. Then we will get all the marks. Then we will be getting 1.25 4.9 0 yes. Then we can find the time value using quadratic equation. There will be two times. One time will be negative. We will pick the positive time, which is 1.25 seconds. That is the time taken for the ball to go up and fall down. We also call it a name. What is that? Time of flight. So remember, during the time of flight, the object will be also traveling horizontally with a horizontal velocity of 3.61 meters per second. Now, then we can use that direction s equals ut, which is equal to 3.61, which is equal to 4.51 meters. Now you can see that 4.51 meters is within. It's more than 3.9 and it's less than 4.7. Therefore, always write the conclusion. The stone lands in the tire. That's the idea. The stone lands in the tire. Then I hope everybody understood that. I'll go a little bit ahead. If they give you the diagram or ask us to draw the diagram, it would have been something like this. Don't make it. Don't do the coloring like that. Always go ahead with a single smooth drawing. Okay. Go along this. Then don't go above than this. Okay. Don't draw like this. Always go ahead with the arrow and below the arrow. Initially go align with the arrow and then go below the arrow. Right. Then the next thing is, in reality, it would have landed like this. Explain. I think you all can remember that that story, the right one. Horizontal velocity is not constant as air resistance opposes the motion. There will be a horizontal deceleration. Therefore, horizontal distance traveled by the object will be lesser than the actual horizontal distance. That is number one. Then number two, the vertical, when the object is in this situation, why, the next question they can ask is why the vertical height reached by the ball is lesser. Why? Then our answer should be what? Vertical motion is under greater deceleration when the object is moving up than 9.81 meters per second square. Reason? Because the object has both weight plus drag opposing the motion. Therefore, maximum height reached by the object will be lesser. That is the next idea. Okay, I think everybody is fine with that. So, if not, it's there in the note. No issues. You can check that, right? That is there with that bad six cricket question. Into my note. Yes. Then the next one. The next question is also a similar question. Back-to-back questions. Scientists launched a projectile from a mountain. The launch site was 2 kilometers above the sea level. The projectile initially moved with a speed of 500 meters per second at an angle of 22 degrees to the horizontal. Show that the projectile was vertically above the ship about 30 seconds after the launch. That means this is going above the ship. What they ask is the time. What we know is horizontally it has traveled 15 kilometers. Do we know at this particular moment what is the vertical displacement? We don't know, children. Therefore, it's a very bad idea to go to vertical motion. Now I'm telling you how I analyze this question. And it's a very good idea to go with horizontal velocity, horizontal motion, because I know horizontal distance. Always remember, if someone gives you the horizontal distance traveled by an object, it's like a bonus for us. Why? Horizontal acceleration is 0. So we can use S equals ut. Horizontally thinking right hand side is positive. S is 15,000. U will be equal to 500 cos 22 towards angle. Time is the one that I have to figure out. So which is equal to 15,000 divided by 500 cos 22. I can find the time which is equal to 32.4 seconds. Then what is your conclusion? Yes. Show that. So we showed. So it rounds out to 30, isn't it? So they don't ask us to conclude anything. It's just to show that question. So we can keep the answer like that. It's like didn't take much time, isn't it? Determine the height above the sea level of the projectile as it passed over the ship. Did ignore the effect of air resistance. That means they want us to find this height. As same as earlier, we can't figure out the height from the sea level. Instead, what we can do is we can find what is the vertical height reached by the object from the launching position, not from the sea level. Okay. Equations doesn't support us because we are using the initial motion from this level. So how does it happen? It happens like it goes up to a maximum height and it falls down on its way. Now it's over here. That is the idea. So start is here, end is here. I have to figure out what is this h. Do you know the final velocity? You have no idea. Do you know the time? Yes, you know the time. That's what you found here. Why? Because when the ball is exactly above the ship, it took a time of 32.4 seconds. So for the ball to go up and fall down also, it took what? 32.4 seconds. So you know the time. Do you know the initial vertical velocity? You know. 500 sine 22. Do you know the acceleration? Yes. Downward 9.81. So enough information is there to figure out h. So I'll summarize my information. My vertical velocity is 500 u vertical sine 22. My acceleration would be downward 9.81. The time is what I need. No, time I know 32.4. I need to find s, which is a doubt. So I'll try to find. Let's take upward as positive. S equals u 50 sine, 500 sine 22. T is 32.4. ut plus half a, that would be negative t square, 32.4 square. I hope all of you understood. I wrote the directions. I wrote a positive direction. And I have substituted in the equation. So we will be getting an answer which is equal to 9.61 10 to the power 2. Roughly, okay. Roughly 9.61. When we type 32.4, you will get a bit of a different answer. So somewhere closer to this. Let's say 9.6 into 10 to the power 2 meters, which is actually 900 and, yeah, and let's say meters. Then what should be the total height above the sea? Total height above the sea would be 2 kilometers plus this. So 2000 plus 961 meters. 2961 meters. You can write like this. They didn't ask for kilometers, so no need to convert. And it's not a flow that also, so no issue. Then they say that the scientists launched several more projectiles. Each projectile was launched at the same speed, but different angles to the horizontal. Then they say, as the launch angle was increased, now understand the concept, okay? Velocity will be the same. What they do is, they are increasing the launch angle. The horizontal distance traveled before landing in the sea increased. Different angles launched at the same speed, but different angles to the horizon. As the launch angle was increased, the horizontal distance traveled before landing in the sea increased. But they are telling the horizontal distance traveled before landing in the sea increased to a maximum value. Then when we further increase, what will happen? And then decrease. It little by little it increased, then little by little it decreased also. Explain why horizontal distance traveled reached a maximum value. You should consider components of the linear. That is a very good hint. So when they say you should consider. Right, you see. When angle to the horizontal increase, what can we say? When angle to the horizontal increase, u cos theta, that is horizontal component of initial velocity decrease. Why did I say so? Because they ask us, you should consider the component of initial velocity. Not enough. And vertical component of initial velocity increase. Always remember that. That means, children, when something is closer to a component, this you can see this u is closer to u actually. So that's why we say when the horizontal angle from horizontal is low, horizontal component is greater, but it has, let's think like that. So the vertical component is less. when it is very close to the vertical component, what can we say? Angle from horizontal is greater, so it's more closer to the vertical component. Vertical component is greater, horizontal component would be lesser. That's an easy way to remember, right? Okay. Now we will move on to the next point. How are we going to analyze? Now, little by little, when we increase the vertical component, always remember, children, vertical component goes with time of flight. I think you can remember the question that we did. To figure out the time of flight earlier, we use the vertical motion rate. In here, to figure out the time of flight, we use the horizontal motion because we know the distance, but time of flight depends on actually the vertical velocity. So vertical component of the initial velocity increases, so time of flight increases. Always remember these two are going together. Vertical component of velocity and time of flight. Right. Then we can say, but now we will address this fact. When the angle to the horizontal increase, this u cos theta, vertical component of initial velocity increase or time of flight increase. Now we'll take this. Horizontal component of initial velocity decrease. Then S horizontal will be equal to, that means we will write it in words. Horizontal distance traveled by the object is equal to horizontal component of the velocity multiplied by the time of flight. So you understood horizontal distance traveled by S horizontal, S equal ut in children, because half at squared part is 0. We told that one thing is decreasing, another thing is increasing, isn't it? That means there is a level where they balance out. So then there is a maximum that the time can also reach. Thereafter, this reduction of UH should be dominating. Therefore, this SH would be reducing. So no need to tell all those things. We will write this equation and then we will say, therefore, the horizontal distance traveled by the object will increase to a maximum and then decrease. That is far more enough in our levels. So there, what is the highlighting part? Suppose that you can't tell this last point, but I believe all of you can tell that when the angle to the horizontal increase, the vertical component of initial velocity increase, therefore time of flight increase, because that is something that you take from home. Plus you can say the horizontal component of the initial velocity decrease. They have told, isn't it? Possible cases. So then okay, then I'll do it again. Now this part is fine. I told about the horizontal component and the vertical component. Always remember, children, when the vector is closer to either horizontal or either vertical, then that will increase. Now, for an example, when theta is smaller, u is more closer to the horizontal velocity component. So horizontal component of the velocity is greater, vertical component of velocity is lesser. Other option is what? When the angle increase, that's what we are analyzing. U is going more towards where? Vertical component. So vertical component will increase, horizontal component will decrease. So when some vector is closer to a particular component, that component will increase. Other one will decrease. That's the idea. Right. Now, the next one. I think I addressed all the matters. It's good that we get these ways. So this one is about the vector diagram. Two forces act on an object. The forces are perpendicular as shown. They are asking the resultant force. One of the easiest questions that they can ask in A levels. 1200 newtons. You know how to draw the vector diagram. Draw one vector. At the end of that vector, draw the other vector in any direction you like. No, in the direction that vector is pointed with the arrow. So hereafter, you can't go anywhere you like. You have to go in the direction that the other arrow is pointing. Then from the start till the end, draw an arrow that will be your result. Now I have a sketch and I understand that it's better to start from this end. 1200. So I will have to get a scale here. Enough space is there. So we will take about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can't go for 1 centimeter shows 100 because then we would need 12. So we will say 1 centimeter shows 200 newtons. 125 is better always. So we have to go with what? 6 centimeters. 1, that means 200 Newton, 400 newtons, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1200 newtons. Then we know that we are going down, that is 2300. So 2300 divided by 200 is actually 11.5. So here. Then draw a line from here to here. Measure that length of the line. They only ask us to determine the magnitude of the resultant force. Magnitude. If they ask determine the resultant force, then that means they are talking about a vector. So find the magnitude and direction both. Theta, tan. Don't take tan theta. Use the protractor and find. This one, use the ruler. So what is the piece of advice? Take a long ruler to the exam. Then measure this length. If this length is somewhere around, let's say, 12.5 centimeter, then it would have been 2500, like just an example, okay, 13 centimeter, 2600 newtons. So magnitude is enough. Right. Now we'll move on to the next force question. The mass of the car is given. Some people sit in the car. The car then accelerates when the resultant force on the car is 460 newtons. Calculate the total mass of the people in the car. F equals ma. Force 460 Newton with a resultant force. Mass we don't know. Acceleration is 0.230. So the total mass that we get is what? Somewhere around, let's say 460 divided by 0.230. Then mass of people will be equal to the total mass. This is the total mass that we are getting. We have to subtract the mass of the car. So roughly, we get 150 kilograms. That's the way to take it, children. Now, I think you can understand F equal ma I have used. with the resultant force and with the acceleration. So what am I getting? Total mass. The total mass is what actually? Mass of the people plus mass of the car. So if you want mass of the people only, what should you do? Mass of the total mass should be subtracted by mass of the car. Then you would get mass of the people. Then in this one, now yeah, no issue. Something came to my mind again. I forgot. I forgot it. I'll tell it again when I remember it. So this is fine. That is the way to take it. Okay. Then we'll move on to the ninth question. If I'm fast, please tell. Okay. Easy questions. I'm going quickly. Uh, in a high jump competition, athlete jump over a bar. An athlete has a weight of 680 newtons. Athlete exerts a force of 890 newton on the ground. He jumps into the car. Yeah. Yeah. Explain why the athlete accelerate upward. Your answer should refer. Oh my God. It's an explanation. It's good. We'll see one by one. In a high jump competition, athlete jumps over a bar. Athlete has a weight of 680 newton. Athlete exerts a force of 890 newton on the ground as he jumps. Okay, what happened is actually, generally when an athlete is just on the ground, he has a weight of 680 newton. He has an upward normal reaction force, which are not Newton's third law pair, because both the forces are acting on the athlete and they are two different types of forces. So they can't be Newton's third law pair. He has a reaction force of 680 newtons. Forces are balanced, he's not going up or down. But what happens is, there is a moment where athlete bends the legs, isn't it? Then athlete still has a weight of 680 newtons. But when the athlete exerts a downward force of 880 newton on the ground will exert an 890 newton on the athlete as a reaction. So in this situation, the athlete has an upward resultant force which is equal to 890 minus 680 newtons. According to Newton's second law, what will happen? The athlete will accelerate. So I hope you all understood the analysis. So what are to be told? No need to tell this one because this is just my explanation. We'll tell this one as well. When the athlete exerts a force of 890 newton on the ground, we would not get a mark for that. But we would have to write the complete statement. By Newton's third law, we will tell the opposite. The ground exerts a force of 890 newton on athlete. The ground exerts a force of 890 newton on the athlete. It's okay. Then we can say what? Therefore, the upward force will be greater than upward reaction is greater than the downward weight force. Because my target is what? Accelerate upward. So my target is resultant upward. Therefore, there will be a upward resultant of, I'm really afraid when they give values, so I'll do a small calculation. 890 Newton minus 680 Newton, which is equal to 110 Newtons. Hence, athlete will accelerate. Oh, your answer should refer to Newton's third law. We will say according to N2, no problem. Hence, athlete will accelerate according to N2. So when we are telling these 3 points, we already have our 3 marks. No issue. I hope all of you are okay with that explanation. I'll tell one more time. When the athlete exerts a downward reaction force of 890 Newton on the ground will exert an upward reaction force of 890 Newtons on the athlete according to Newton's third law. Therefore, there will be an upward resultant force of 210 Newton, which makes the athlete to accelerate. That way is better, I think. Right, now we'll move on to the next one. The athlete moves horizontally as he passes over the bar. The bar is there. The athlete is now, what happened? The athlete is now moving horizontally when he passes the bar. The kinetic energy of the athlete is 409 joules. Show that the athlete has a horizontal speed of about 3.4 meters per second. Very simple, isn't it? How to find? Half mv squared. 409 equal half m is the problem. Do they tell the mass of the athlete? They have already told us the weight of the athlete, 680 newtons. So using W equal mg, we'll try to find the mass. (680 Newton) divided by 9.81. Children, always better when you do, now I'm using this in here and doing the calculation. It's always better when you take this way. Not this way. Always better to get the answer and substitute it. 69.3 and then substitute 69.3. Why? If something goes wrong, at least you get this mark. Then we'll substitute 69.3 here. Then we'll take v square. You will be getting a v value of 3.436 meters per second. Then the next question is, after passing over the bar, the athlete moves through a vertical distance. After passing over the bar, the athlete moves through a vertical distance of 1.4 meters before he lands. Calculate the velocity of the athlete as he lands. Now we understood that initially we understood that the kinetic energy of the athlete is 409. They ask us the velocity of the athlete as he lands. Velocity of the athlete as he lands. It's a very good question because we have everything to be considered now. Uh, they are telling after passing over the bar, athlete moves through a vertical distance of 1.4 meters before he lands. So one very important information they have told that when the athlete passes the bar, he has a horizontal velocity only. That horizontal velocity we have figured it out 3.436. 3.436 meters per second. So even when he lands also, still the horizontal velocity would be what? 3.436. Why, children? Horizontal velocity is constant. Why? Horizontally, there are no air resistance, assuming, therefore, horizontal velocity is constant. That is the idea, right? Horizontal velocity remains constant. Then we can say he is falling vertically under gravitational acceleration. And he falls through a vertical height of 1.4 meters. I think you can remember I told you how to find the velocity. This is a very good question which covers another part of projectiles. So, you know, horizontal velocity, final horizontal velocity, which is equal to what? 3.436. You can find the final vertical velocity. How? Initial vertical velocity will be zero. Why, children? Because at this instant, the person is traveling horizontal. So he has no vertical velocity. So I will use thinking downward as positive. S equals ut plus half at squared, which will give me 1.4 equals, there is an issue. I don't know the time. So don't go with that. We'll go with v square equal u square plus 2as. Not analyzing properly. V square equal u square plus 2as. Final velocity, we don't know. Initial velocity is 0. Acceleration is 9.81 because we are considering the vertical velocity here. Then what is the vertical displacement? We have trouble 1.4. So we can find the vertical velocity, which is equal to what? Square root of 2 times 0.81 times 1.4, which is equal to 5.24. Okay, I'll summarize the question again. The question told us that when the long jumper passes the bar, he is only traveling horizontal, which gave us the indication that he doesn't have a vertical velocity. Thereafter, the person should fall down, isn't it? Because after horizontal, then due to the gravitational acceleration, falling part. The question tells he falls 1.4 meters. Question asks the final velocity. So to find the velocity, I need the vertical component and the horizontal component. Horizontal component of the velocity doesn't change. But vertical velocity is increasing as he falls down. I don't know anything about the time, but I know the distance, acceleration, initial velocity, final velocity. That's why I use v square equal u square plus 2as to determine the final velocity. Then I can draw the triangle. Horizontal velocity is 3.436. Vertical velocity is 5.24. We drew one vector At the end of that, we drew the next vector. Then we get what? The resultant vector. So by using Pythagoras theorem, 5.24 squared plus 3.436 squared square root, we would be getting a value from. Then angle from vertical. Angle from vertical. Angle from vertical, we can take tan inverse, isn't it? This angle from vertical, tan inverse 3.436 divided by 5.24. That is the angle from vertical. Analyze this question, and if you have any doubts, ask me, children. It's a very long question.
Excuse me, sir.
Yeah.
Can we use gravitational potential energy to kinetic energy and then find the velocity?
Can velocity in the sense, so now we would be getting actually if we are using gravitational potential energy and kinetic energy equation, we will be getting actually the speed. So it would be okay to determine the magnitude of the velocity. That gives us the speed, but then there comes a problem. The problem is actually we will not be able to determine the angle, isn't it? Because we only know the horizontal velocity. We can do like this. Yes, another option is there. If we use GPE and KE conservation, what we can do is we know the speed, the magnitude of the velocity, and we don't know the vertical angle, but we know its horizontal component is 3.436. It implies that the value that we got, that is 6.27, it would be the same. Sine theta will be equal to 3.436. From that, theta equals sine inverse, we would get the same answer. Possible. Again, I'll tell Sonari, we can find the final speed. When we find the final speed using GPE and kinetic energy conservation, we will be getting the same answer because that is the magnitude of velocity. Then we know the velocity, we don't know the angle, but we know that its horizontal component will be 3.436 because it doesn't change. So we can write V sine theta will be equal to 3.436. We know theta will be equal to sine inverse 3.436 divided by the value of V that we found. Possible. Yes. Can get marks. So it's a 11-mark question. These types of questions, they appear in the last part of the paper. However, I think you all understood. Still, if anyone needs any analysis, tell me, I'll explain, right? Now we move on to the 10th question. This is a 6-mark star mark question, explanation type. Read and see. Okay, children, we'll see the 10th question. They are running the tension. A student is about to do a bungee jump from a high bridge. The student is attached to the bridge by an elastic rope. The student jumps from the bridge and initially accelerates. Now, something good for us to keep. The diagram shows the student at three different positions during the bungee jump. Position A, distance fallen by the student is equal to the original length of the rope. That means, children, the rope is not under extension, isn't it? It's not under extension. It's equal to what? Original length of the rope. Student is equal to original length of the rope. At B, the student is in equilibrium. Resultant force will be 0. Then they say the position C, the rope has maximum extension from the original length. The rope has the maximum extension. Here tension is greater. Here weight can't change. Weight is there. As it is just, there will be a tension. Right. Explain how the acceleration of the student changes as she moves from position A to position C. Right. Let's say from position A to B. What can we say? Tension is lesser than the weight. Why, children? Because the extension is smaller, so tension should be small. Actually, in this one, it's almost equal to 0. Then even if we can say it's 0, no issue, but we are talking about between. Okay, between A to B, the tension would be, this is the place where the tension become equal to weight. All the previous situations, we know that force and extension are directly proportional. So in this case, with the tension and extension are directly proportional. So this is the level where the tension become equal to weight and resultant force becomes 0. All the other places extension is smaller, so tension should be smaller. That means it should be smaller than weight. Then what can we say? Resultant force is downwards. Therefore, what can you tell about the acceleration? How the acceleration, that's why I'm talking about the acceleration, is downward. Right. But we can say few more things. When extension, because we have to tell about the acceleration. Okay. When extension increases, now I'm trying to tell you the way to think to answer a 6-mark question. Think, it's very, very sensitive. Even any mini parts. Now I should have told tension is greater than the weight, therefore resultant force is downward, hence the acceleration is down. Then I should have gone from here to here also. I would have told tension is greater than the weight, therefore the resultant force is upward, hence the bungee jump is decelerating. But the thing is, I would have missed the part of what? Here to here, the tension increasing, resultant force is decreasing, not that negative. Resultant downward force is decreasing, so acceleration is decreasing. That part is there, isn't it? That's why we have to tell about that. Always check. Go back and check whether you miss something. We can say when extension increases, what can we say? When extension increases, the tension also will increase. Therefore, still the resultant force is downward. Okay. Therefore, downward resultant force will, what will happen? Resultant force is what? Weight minus tension, decrease. And acceleration will decrease. Now we are happy because we told about that. Then we will move on to exactly B because that is a special case. At B, tension is equal to weight, resultant force is equal to 0, acceleration will also be equal to 0. Sorry. Then we can say from B to C, what can we say? Tension will be greater than the weight. Now we will tell the same thing. Tension is greater than the weight. Tension is greater than the weight. Resultant force will be upward. Acceleration will be upward. Therefore, the student will be decelerating. Then I will like to proceed this one. When extension increases, tension will increase. The upward resultant force, tension minus weight, will increase. Deceleration also will increase. So everything is addressed. Actually, now we all know that this question would not appear again, isn't it? So why we discussed is rather than the answer, the way to think to get marks is the most important thing. That's the reason, right? Then we'll move on to the next question. Part B. The bridge is above a river. The student will reach the river if the rope stretches to a total length of 35 meters during the bungee jump. So, in other words, they are telling here to the river, the gap is 35 meters. The student has a mass of 65 kilogram. Original length of the rope is 17 meter. Rope behaves like a spring. As soon as they say I have to remember F equals K delta X equation. With a stiffness constant of 250 Newton meter, that means they have given us the K value. That's the idea. Okay. So from where the student jumps? 35 meters. The bridge is above a river. If the rope stretches to a total length of this, so the student jumps from here. Now, the thing is, if you feel like doing this question in terms of forces, that would not be a very wise idea. Why, children? Force is, in the previous explanation, we told force vary, acceleration vary. We can't use SVUAT. Equations of motion cannot be used. Therefore, in places, can you remember the start of this discussion? I told in places where acceleration vary, our friend is energy. In places where you find acceleration vary, it's always energy that comes to help. So we will think like this now. When the person jumps, his initial velocity is 0, so kinetic energy will be 0. But as 35 meters above, he has a GPE. You can draw diagrams, you can label, you can use it while you are answering. At A, GPE, it's equal to M65, G 9.81, H is 35. Now suppose the bungee jumper falls a particular height which we don't know. Okay? Then what will happen is his GPE will reduce. That is the idea. The original length of the rope is 17 meters. So, however it is, until 17 meters, the rope will not stretch. Thereafter, only the rope will stretch. So we will think that the bungee jumper hits assumption. Okay. We will see what is the energy required for the bungee jumper to fall 35 meters from the starting position. Two stories are there. Until bungee jumper reaches 17 meters, the only conversion is GPE to KE. I hope everybody can understand. But thereafter, until he lands or reaches the sea, can you remember there is a particular level that even the kinetic energy also reducing? Because we told in the previous question, decelerating. After a particular level, all GPE and the kinetic energy. So until here, what happens? Gaining kinetic energy, until here also gaining kinetic energy, and elastic potential energy is also gained. But at the end, all the kinetic energy gained and all the GPE will be turned into elastic potential energy. So who gave the kinetic energy? Reduction in GPE gave kinetic energy. So no need to worry about kinetic energy. All will be handled by GPE at the beginning. So when it hits the ground, all GPE will be turned into elastic potential energy. Now we'll see at B, elastic potential energy. That will be equal to, what is the extension? From the start until 17 meters, no extension. Okay, thereafter only extension. The total distance is 35. The total distance is 35. So tell me what is the extension then? That would be 17 minus, so 35 minus 17. Half F delta X. We don't know the force. F equals K delta X is there. So half K delta X squared is also possible. Half K 250 delta X will be equal to 35 minus 17 squared. That would be the potential energy required by the bungee to reach the sea level, which is equal to 40,500 joules. But the gravitational potential energy at the beginning is just 22,300 joules. So what is your conclusion? Even if all these GP is transferred to EPE, it's just 22,300, not enough to reach the ground. Then our conclusion, 40,500 joules required It's greater than 22,300 available. Therefore, will not reach the river. That's the question. That's the answer. Right. I hope everybody understood. This one. This was also appeared in the last question, as the last question in that particular paper. The zip line consists of a cable fixed at 2 points, one higher than the other. Person hangs from a wire attached to a wheel as shown. The wheel can move along the cable. The wheel moves the person along the cable. In the position shown, the person is accelerating. Complete the free body force diagram below to show the three forces acting on the person in this position. Right. Now, on who? On the person. Remember, there is a wheel. The person is holding the wire, okay? And always there comes a word either moving at a constant speed or accelerating. In here, the word is accelerating. Okay, don't think of these cables and all, because the person is attached to the wire. The wire has given a tensile force away from the person's body along the wire. The person also have a weight force. The person is, if the person has a velocity this way, opposing the velocity, there should be a air resistance that should not be horizontal. Okay, right. Then we will see. Along the cable. You are taking a ruler to the exam. So using the ruler, draw a parallel line to this one. Not like me. Then this would be what? Force from the wire on the person. It's already there. Ne? Force from the wire on the person. Then downward we have what? Weight of person. Then person is moving this way. Therefore, drag force will be this way. Drag forces are very too small. So we can mark air resistance as the person is moving through air. If it is a fluid, we will have written drag. Even in this instant, if you write drag, it's completely fine. You get marks. Then we will see. It's not necessary. We will see the next question. The next question, they say that at a particular instant, the tension in the cable. Now, this is about the cable, okay? The tension. Now, in the cable is 1200 Newton, and the angle formed by the cable at wheel is 144 degrees as shown. Show by calculation that the force on the wheel from the cable is about 740 Newton. Okay. Then what we can find here, it's a 2-mark question, isn't it? 1200, 1200. We have to find what the force on wheel from the cable is about 740 Newton. So I'll draw one vector. At the end, I'll draw the other vector in its direction. 1200. Then from the start, of the first vector till the end of the last vector, I will draw the resultant force. That is the resultant force acting on the cable, the force on the wheel from the cable. Now, when we look at this one, what we see is this is also 1200. This is also 1200, isn't it? This would make a trapezium because this length is also the same, this length is also the same, this length is also the same, this length is also the same. It's actually rhombus in this case. If it is so, then as it is a rhombus idea, this angle should be bisected, isn't it? 72 degrees. This one also will be what? 72. Why? It's a isosceles triangle. Two sides are equal. We have to find this length now. So about isosceles triangles, if you can remember, when we draw a line to the center, it's 90 degrees and bisects 1200 cos 72. And this one is also 1200 cos 72. Total would be what? 1700 cos 72 plus 1700 cos 72. 1200 cos 72. That would give us this length because it's a right angle triangle plus 1200 cos 72. Why I thought of it like that is because it's just a 2-mark question. Otherwise, we can think of it in a very deep way also, which is not required at this instant, isn't it? Right. Then, however, you had a good idea when we draw a line. This is a special case only, children. The reason is these two forces are equal. Okay, that's the reason. Then generally it would have formed a trapezium, but in this case it forms a rhombus. So this angle bisected to 72. This is also 1200. This is also 1200. This will also be 72 then. Isosceles triangle. Then in an isosceles triangle, when we draw a line to the midpoint of the third base, it would be perpendicular. So we'll use a little bit of trigonometry. This is 1200 cos 72. This is also 1200 cos 72, which will be giving us the total length. Right. That is also fine. Then a 4-mark question comes. There is a force on the wheel from the wire. There is a force on the wheel from the wire of 800 Newton. The angle between the force from the cable and the 800 Newton force from the wire is 150 degrees. Determine the magnitude of the resultant force on the wheel using a scaled vector diagram. Okay. Earlier, we figured out that the force on the wheel from the cable is this 742, let's say. There is a force on the wheel from the wire. If we understood that the cables are there, this angle would be 144 degrees, 140 degrees. 144 degrees, and there will be a force of 800 Newton. The angle between the force from the cable and 800 Newton force from the wire is 150 degrees. Right. Determine the magnitude. Now what we have to do is, first of all, we will draw 8 centimeters. Doesn't matter which direction, because we have to draw just a scale diagram. So I'll draw something parallel to this line that I have drawn. How many centimeters? 8 centimeters, representing what? 800 newtons. Then children, I have starting point, isn't it? To that, we will keep the protractor. The cross is at the start. From 0, measure 150 degrees. Put a cross. Then join that line and mark what? 742. That means 7.42. We can't mark 7.42. We will mark 7.4 centimeters, representing 742 newtons. Ah, I'm wrong. Why am I wrong? I drew not from the end, but from the beginning. Forces are drawn one after each other. Okay, good lesson. Then I finished 8 centimeter from here. I have to measure 150 from 800 moving away direction, isn't it? So I'll keep the protractor here. Zero line, a little bit extended line of 800 with dotted lines. We'll measure 150 from here. Then I will mark 7.4 centimeter. Now, okay. Then what should I do? Using the ruler, join these two, measure the length. That is the result. Resultant force to measure the length multiplied by 100. We'll be getting an answer for that. Then the next question. People take turns at moving along the zip line from high point to the low point. The people are initially at rest at high point. Explain why speed of people with different masses are always above the same. Very famous question when they reach the low point. I think you can remember we proved this, isn't it? But we did one assumption. These masses cancel off. We equal this. That's enough. Okay, we'll move on to the next one. A train moves up an inclined track at a constant velocity. The train moves through a vertical height of 25 meters. Show that gravitational potential energy gained by the train is this one. So it's simply mgh 1.7 into 10 to the power 6, 9.81 into 25, 4.17, 4.17 into 10 to the power 8. Then the next question, the train engine has an output power. P is given 20 multiplied by kilo omega 10 to the power 6 watts. Then they are telling time 35 seconds to move through a vertical height of 25 meters. Calculate the work done by the engine against the resistive force. So first of all, with the power and time, we can calculate the energy that is given by the engine output. 20, 10 to the power 6, 35. 7 into 10 to the power 8 joules. This is the full energy given by the engine. But what is the GPE gained by the train? Only this much. So what is the work done against the resistive forces? From 7, the full energy given by the engine, we have to subtract the real energy that was useful for the train. Then we will be getting work done against resistive forces in joules. That's how we get it. That's a very simple question. Then the next one. Escape lane can stop cars or trucks safely if the brakes stop working when moving downhill. The photograph shows an escape lane. The escape lane is made of sand and is horizontal, as shown below. Is horizontal, okay. Some escape lanes are there which are having an angle also. The resistive forces of the sand on a vehicle reduces the kinetic energy of the vehicle. There, work done against the motion. As the truck enters the escape lane, kinetic energy of the truck is given. So work done by the resistive force given by the sand also should be equal to what? This when the vehicle fully stops. I think everybody understood. It has kinetic energy of 18 to 10 to the power 6 joules. When it stops, it has to have a kinetic energy of 0 joules, isn't it? So what has happened then? There was a resistive force that was applied over a distance of particular delta x. We don't know, or d. That force into distance should be equal to what this. Then only it made it 0. In which form does it transfer? Thermal energy stored to the surrounding, to the sand, to the tires. Calculate the distance moved by the truck. Very simple, isn't it? 8 into 10 to the power 6 joules is the energy that we need to reduce. That is reduced by a particular force which is equal to 3.5 into 10 to the power 5 and distance d. So we can find that equal 8 into 10 to the power 6 divided by 3.5 10 to the power 5, which is 22.9 meters. I hope that is also okay. Then children, the next one. They say the resistive forces exerted by the sand on the vehicle is proportional to weight of the vehicle. Resistive forces are directly proportional to the weight of the vehicle. The weight of the car is less than weight of the truck. So the resistive force also will be lesser, isn't it? Explain how the deceleration of a car on the escape lane would compare with the deceleration of a truck. Right. Now, when we consider this one, what we can figure out? Deceleration, as they talk about deceleration, we can target what? F equal ma, isn't it? Then we can say that proportional to the weight of the vehicle, right? So when the car is moving, the only force acting on the car is what? The resistive force, which causes the car to have the deceleration ma. Then they say that this is directly proportional to what? Mg, isn't it? Right? So it implies that MA will be directly proportional to what? Mg. A will be directly proportional to what? G only, isn't it? So what is our conclusion? So you saw that now two questions, back-to-back questions were cancelling mass. So what is the thing? Newton's second law applied on the resistive force, which caused the car to decelerate. That's why I was encouraged to write F equal ma. Then I wrote what they told, directly proportional to the weight, and I substituted what is F. Mass cancels off. Acceleration is only directly proportional to G. Not actually acceleration, deceleration. Therefore, deceleration does not depend on the mass. Not enough. I have to compare. Therefore, car and truck both have same deceleration. That's the idea. Okay. Then the next question. The next energy question. There's a hydroelectric power station in Scotland. Water from the lake is going down through the pipes, having a distance of 350 meters at an angle of 55. I think you can understand that would be helping us to find the delta H value. The gravitational potential energy of the water in the lake is used to generate electrical power. In 1 minute, the pipe transfers this much. 1 minute, volume is 1700 meter cube. The density of water is given. Show that the power transferred by the water in each pipe is about 88 megawatt. You see? So I will find delta H first then. I know that power is equal to what? Work done divided by time. So time is 1 minute 60 seconds I can use. Only thing is work done, I have to use mgh. To find the work done, that is the gravitational potential energy reduction is transferred to the work done of the generator, isn't it? I need to know M and H. That's why it carries 5 marks. So now you see it's not hard. H, how to find 350 sine 55. Then what is M? Density equal mass or volume. Mass equal density multiplied by volume. Density 1100. Volume 1700. So now we'll use as I told earlier, always better to do the calculations and get an answer. So for my easiness, I'll carry forward these values. 350 sine 55. So MGH, then I will put that answer over here. 5.26, 10 to the power 9, which will lead to 87.7, 10 to the power 6 watts, which is 87.7 megawatts. So a 5-mark question became very easy. Water travels from the lake to the generator through 4 identical pipes. As water moves through the 4 pipes, the generator's total power wasted is this much. Very cunning, isn't it? Calculate the efficiency. Efficiency is equal to useful divided by total. So the total will be not this, 4 times this. 4 times 87.7 megawatts. Useful would be from 4 times 87.7 total input, I have to subtract the wasted of 256 multiplied by 100%. Or you can even omit 100%, doesn't matter, then you will get a ratio of 0.27. If we use 100%, we will be getting 27%. Remember, children, if you don't use 100%, your answer would be 0.27. If you use 100%, it would not be 27. That is asking for trouble. It should be 27%. Percentage mark is very important. Right, that's done. Then the next one. Now, children, we have come across a long way. Projectile to forces, motion to forces, forces to energy. Now, how many things are there? Momentum, moment, fluids, and what? Solids. Fluids are the most frequent questions according to the analysis, right? So there is about 6 questions from fluids. These moment, very less number of questions. We'll finish moment, and have a little bit of a break and start. I think everybody's okay with this thing. If you have any suggestions or if you need a break any more, tell me, right? That's why this is not a physical class, because I can't drag a lot of time in a physical class. You also get fed up. Now you are in a comfortable seat and all. Sometimes maybe on the bed and sleeping. So we'll see. Then, um, right, we'll see. State Newton's third law applies to the glider during collision. Teacher uses an air track and 2 gliders A and B. Demonstrate principles of conservation of linear. Glider A and B moves towards each other and then collide. Ah, when glider A exerts a force on glider B, the glider B will exert equal and opposite force on glider A. Simply we can say. Deduce whether the prediction is correct. Gliders stick together in the collision. Student predicts that gliders will move to the left after the collision. We'll see. We don't know the velocity after the collision, so no need to put a direction. But I will consider an initial direction, right hand side is positive. Mass of glider A 0.15, velocity of glider A 0.32, plus mass of glider B 0.20, velocity of glider B negative 0.11, because it is opposite to my positive direction. This is what? Initial momentum total. It should equal to what? Final momentum total. What is the total mass? Because they are combining. 0.35 velocity. You would be getting a positive answer here. 0.074 meters per second. Then, if you get a positive answer, it tells us what? It tells us that it obeys my positive direction. Therefore, they move off towards right hand side. Now, those who did M1, they may be thinking, how can we write left hand side, right hand side? That's prohibited. No, because they have given us the diagram, they have given us the directions. It's not us who drew the direction, so we can say right and left. No problem. What is the prediction? Move to the left. So you would not get the third mark. You have to tell about the prediction. Therefore, the prediction is wrong. Now, students are writing all these things, forgetting the prediction. So don't forget, we'll write the prediction. Okay, right. Then, 16th question. Two identical balls A and B collide. Initial velocity of ball A marked. Then they have marked this is at rest, 0 meters per second. Then show that the velocity of ball A immediately after the collision is about 0.05 meters per second. Right. Show that the velocity of ball A. Again, the same thing, isn't it, children? What to do? Sometimes they give us the momentum, then the questions would be very easy. Identical sphere. So mass of A is still m. Velocity, I think right hand side is positive, children. 0.739 plus 0. Why 0? This doesn't have momentum. Mass of A, velocity of plus mass of B, velocity of B. I think everybody understood. What happens then? Everywhere mass gets cancelled off. Little bit of a simple calculation is there, 739. It's equal to V plus 0.691. Then this goes to the left-hand side. Subtract. You would be getting an answer 0.048 meters per second. That is right. Okay. Then the next one, children. They say before the collision, the kinetic energy of ball A is this. Why do they give us this kinetic energy? Determine the decrease in total kinetic energy. Ball B is 0. Because children, you will not be able to find the kinetic energy after the collision if you don't know the masses, isn't it? So, using the kinetic energy of A, which is equal to half mv squared, initial velocity is known 0.739. I think I told you many students forget the square. Don't forget the square. Then 2 times 4.5 into 10 to the power minus 2 divided by 0.739 squared would give you the mass. Then why do you need the mass? Use the mass, you can find the final kinetic energy. How do you find the final kinetic energy? Half into mass is what we found from here, which is equal to, do they give us the mass at any moment? Oh, they have given us the mass, 0.615. No need to find the mass, children. Overthinking, not reading the question properly. I did so many mistakes. So don't do that. Read the question carefully and identify the information given in the question. Mass of each pole is given 0.165. Even we could have used it here. Doesn't matter. However, the masses are cancelling off. So no need to worry about that. EK after, which is equal to half 0.165, 0.048 squared plus half 0.165, 0.691 squared. When we add them, we will be getting a final total kinetic energy of 3.96 10 to the power minus 2 joules. Then we can say the reduction, this minus this minus this. That's all. Right. Then part C. During the collision, there is a resultant force on ball B from ball A. Children, now when we see this word resultant force, then there is a problem. Then how can we say momentum is concerned? It's okay. Why? We say no external unbalanced force. No external word is there. Internal forces are okay. External forces, air resistance, friction, those are the things. Explain in terms of Newton's laws why ball A decelerate during the collision. Right. Then I think you can remember the previous question. This was from another paper. This is from another year. Then it's always better to tell, isn't it? According to Newton's third law, B exerts an equal and opposite force on ball A, isn't it? According to Newton's third law, now we are talking about why A is decelerating. So we can say when A exerts a force on B, B will exert an equal but opposite force on A. Which direction? Opposite to the direction of motion of A. Not enough. We have to talk about the resultant force to go for deceleration as well. Therefore, there is a resultant force opposing the motion of A. According to Newton's second law, ball A will decelerate. Right. Momentum is done. Now moment. Children, I think you all are not tired. 17. A bicycle pedal is connected to a circular chain ring by a lever. Person of weight W stands on pedal. Determine moment of W about the pivot when theta is 24. You all know, children, force line can be extended as much as we can. Can you remember the basketball question that we did? Basketball or volleyball question that we did? Similar case. From the pivot, only requirement is you have to draw a perpendicular line to the force line. The line that you draw and the force line, they must be perpendicular. We have done more harder questions than this, like the door question, isn't it? Then we have the weight force, 580. The length of the lever arm is there 0.21 meters. We have to take the adjacent of that. This is the hypotenuse. So this length would be what? 0.21 cos 24. I hope everybody understood it. So we have what? 580 Newton multiplied by 0.21 cos 24. That is the way to get it. Then you will be getting somewhere around 111 Newton meter. That is totally fine. Then the next question. The chain ring exerts a force F on the chain as shown. F is proportional to the moment of weight about the pivot. This length, let's say T, then the perpendicular distance would be what? D cos theta. That's what they told. Explain how F changes as theta increases from 0 to 90. All right. So that means this pedal can go up to here. So theta can increase from 0 to 90. As soon as I saw this question, this is what I marked, because you saw that there were proportional questions at the beginning also. So children, tell me, when theta increases, you know in small days about the cosine graph between 0 to 90. This is the cos graph, isn't it? Then what is the sine graph if you want to know? That would look like this way. You know, isn't it? Then tan graph, this way, 0 to 90. So when theta increases, what happened to the cos theta values? Y-axis gives the cos theta value, reduces. In here, what happens when theta increases? Cos theta, sin theta values will be increasing. In here, cos theta values will be initially very high, it's at 1, then reduces to 0. Cos theta reduces. When theta increases from 0 to 90, cos theta reduces. Or that is something that I gave you. Can you remember that the other thing that I told? When we move away, the weight is however there. Can you tell about the distance component? Can you remember the horizontal component? When we are moving away, what did I tell? Alicia asked me that question, so I repeated. So what happens when we move away? The theta increases, the horizontal component of the distance will decrease, isn't it? So we can tell even that way also. Some students can say theta increases, cos theta decreases, therefore the force will reduce. As the force reduces, because the moment reduces. Some children can say, like the usual way, when theta increases, horizontal, perpendicular distance from pivot to weight reduces. The component is reducing. Then what can we say, children? Therefore, the moment reduces. And what will happen? They are directly proportional, isn't it? Force F will reduce. Okay, that's right. Then another moment question. They are telling the balance is formed by beam. A balance is formed by a beam suspended from a string. A dish is hung from the beam, and the balance is used to measure the fixed portion of rice. When the dish contains one portion of rice, the balance is in equilibrium as shown. Say the condition needed for an object to be in equilibrium. I think you can remember we discussed this. What are the two conditions required? Resultant force in any direction should be equal to 0. What is the second condition? Resultant moment about any point will be equal to 0. Again, I will tell resultant force in any direction is equal to 0. Second one, resultant moment about any point is equal to 0. Right. Then the next question. The dish is moved along the beam so that horizontal distance from the string to dish is 7 centimeter. Will happen. This will make a anti-clockwise rotation, isn't it? Rice is added to the dish until balance is in equilibrium again. Deduce whether dish now contains 3 portions of rice. You should include calculations of the weight of one portion of rice. Of the weight of one portion of rice is required. Weight of the beam is given 3.1 Newton. Weight of the beam, center of gravity of the beam is there. The weight of the beam they have marked. The weight of the beam is 3.1 Newtons. Weight of the empty dish is 0.64 Newtons. So forget about the weight of the empty dish. First of all, we will consider the balance condition. Weight, we don't know. So very easily we can figure it out, doesn't it? 3.1, that causes the center of gravity from the beam. This is the pivot. From the pivot to the weight, it causes an anti-clockwise moment. Distance is 8. No need to convert because this is also centimeters. The only clockwise moment is caused by the weight of the dish and the rice. So weight of dish and the rice will be W. Remember, that is the total multiplied by 25. So weight of dish and rice will be 3.1 into 8 divided by 25. That would give us the answer of weight of dish and rice, which is equal to 0.992 Newton total. Then weight of rice portion, weight of empty dish, they have given 0.64. 0.992 minus 0.64, which is equal to 0.352 Newton. I hope all okay with that. Then that is also fine. Then the next thing is, now we found weight one portion because they're asking us calculation of weight of one portion of rice. We figure it out. Now we'll move on to the new situation. We'll consider 3.1 is there. So it would cause an anti-clockwise moment, 3.1 multiplied by 8. It should be equal to 7 times some kind of a weight, isn't it? Then we will figure it out then. Figure out that one. This would be the total weight that is required, isn't it? Then total required. Then weight of rice will be equal to 3.1 into 8 or 7 multiply minus 0.64 again. Which should give us 3.1 multiplied by 8 divided by 7 minus 0.64, 2.903, 2.903 newtons. Then how many portions? Number of portions. This should be divided by 0.352. This much of rice is needed. One portion of rice contains 0.352 newtons. So the number of portions would be roughly 8.247. So we need how many? 8.24, not 3. Therefore, statement is wrong. Right. Okay, then the next one. The last moment question. The last question is of the moment, okay? A lorry is crossing a bridge. The bridge is supported by 2 columns as shown. Forces P and Q act on the bridge from the columns. The center of gravity of the bridge is at its center. At a particular time, the lorry is 35 meters from point X. A simplified diagram showing the positions of the forces on the bridge is shown below. Calculate the magnitude of the forces P and Q. You should take moments about point X. They are guiding us also. So we'll take moment about point X, this point. When we take moment about point X, now help me. Force from the lorry. Do they give us the weight of the lorry or mass of the lorry? Because I learned a lesson earlier, not reading the question carefully. Uh, they have, yes, weight of the bridge is also there. 4.2 10 to the power 5. Weight of the bridge, 9.8 10 to the power 5. We'll take moments now. Tell me, this is causing an anti-clockwise or clockwise? Clockwise. This is causing clockwise. This is causing an anti-clockwise. About the pivot, just keep the pen and rotate. So this side we'll write clock, this side we'll write anti-clock because it is in equilibrium. 35 times 4.2 10 to the power 5 plus 35 plus 25 makes it 60 times 9.8 10 to the power 5 should equal to 60, 60, 120 times force at Q or force Q. So it's simply Q. So we will be getting Q, which is equal to 6.12 10 to the power 5 newtons. No issue. Then the next thing is P. How do we find P easily? Now you know force Q, isn't it? Resolve forces vertically and up and down. They are equal because that's what we learned earlier at the beginning, isn't it? What is the reason? Resultant moment about any point is 0. Resultant force in any direction should be 0. Resultant force also should be 0. So upward force, force P plus force Q should equal to downward forces, this plus this. Then force P will be equal to addition of these minus Q. That will give us 6.12 into 10 to the power 5. Sorry, it's this one. So that will give us 7.88 10 to the power 5 newtons. Don't forget the units. That is also there. Then the next question, explain why force Q increases as the lorry moves across the bridge. This is like an O-level question, but for 5 marks, okay? Then I will tell general reasons that we are telling. However, tell me, now this is X and this is X, right? Yes, X. Let's label this as Y because it's easy for us. Lorry is there, X is there, Y is there. Now, tell me, even at any moment, would the bridge rotate? No. So we will start by telling that this is actually from those who did Edexcel, IGCSE, O level, same thing. Okay, no difference at all. Then we will say the bridge is at equilibrium. Therefore, sum of moment about any point is equal to what? 0. Therefore, sum of moment about any point is equal to 0. That is, I think everybody can understand we have to write, isn't it? Then we will say like this. This question comes in several ways, but the answer is the same. Okay. Then we say, now you can understand that when the lorry is moving, actually the weight of the lorry is moving, isn't it? So we say distance from X to the weight of lorry increase. Therefore, clockwise moment due to weight of lorry increase. That is, I hope everybody can understand that. Therefore, clockwise moment due to weight of lorry will increase. I hope everybody can understand that. Distance from X to the weight of lorry increase. Therefore, clockwise moment due to the weight of lorry will increase. Actually, I would have told this over here. Distance from X to weight of lorry increase, clockwise moment due to weight of lorry increase. At equilibrium, sum of moment equals 0. Hence, the anti-clockwise moment by Q will increase. About X. Distance to Q is the same. So, how do we, if the distance is the same, and if we need to increase the anti-clockwise moment, only option is force Q should increase. Again, I'll tell, weight, the clockwise moment caused by the lorry's weight about X increase because distance to the lorry increases. The beam is in equilibrium, so total clockwise moment should be equal to total anti-clockwise moment. So sum of moments about X should be 0. Hence, if the clockwise moment increase, anti-clockwise moment also should increase by equal amount. But to increase the anti-clockwise moment, since the distance to force Q is the same, only option is what? To increase Q. That is right. Okay. Right. Then we did motion. We did revised about force, energy, momentum, moment. How many things are left, children? Only 2. Fluids and solids. We'll see. I think you all are. okay and still in a position to absorb. Anyway, I'll give 5 minutes not to leave, just to stretch your arms and legs and drink some water and come. Only five, okay, not more than that, because I have 9 more questions to discuss. Right. Uh, this one, they say an iceberg is a large mass of ice that floats in seawater with most of its volume below. The surface of seawater, the photograph shows a typical iceberg. The iceberg can be modeled as a rectangular block of ice. Particular iceberg has 6.7 total height below the surface of the water as shown. So I will remind you a little bit about this fluids thing. If anything is floating, then the idea is, children, that is the idea, weight is equal to upthrust. Then weight is what? Weight is the density of the object, volume of the object, gravitational field strength. Upthrust is equal to what? Density of the fluid. Density of the fluid. Okay, density of the fluid multiplied by volume of the fluid displaced, which is equal to volume of the object inside the fluid multiplied by gravitational field strength. Very simple idea. Now we will see. The block of ice has a horizontal cross-sectional area of 3,500 meters square. Calculate the weight of the block of ice. Density of seawater is given. Right. Now we will see. An iceberg can be modeled as a rectangular block of ice. A particular iceberg has 6.7 meters. They are asking, calculate the weight of the block of ice. They have given us the cross-sectional area. Density of seawater is also given. So in this question, what we can do, my eyes actually went to this thing, the density of seawater. As soon as I see density of seawater, it's not actually the iceberg, it's talking about upthrust. So I should know that calculate the weight of block of ice. They are requesting us to use what? Weight is equal to upthrust. We'll see, okay? That's the first idea I got. We'll check whether enough information is there to go ahead with upthrust. To find the upthrust, we need volume of the displaced fluid, gravitational field strength, and density of the displaced fluid. Right. Then volume of the displaced fluid is there. Volume of the displaced fluid is 3,500 multiplied by 6.7, because volume of the displaced fluid is equal to the volume of the iceberg inside the fluid. Okay, that's how we take it. Then cross-sectional area multiplied by height is 6.7. G is 9.81. We need the weight of the block of ice. Density should be used. Density of seawater is 1.03 10 to the power 3. So we will be directly getting our answer 2.37 10 to the power 8. So children, what is the thing that we used? Weight of the iceberg equals what? Upthrust acting on the iceberg. These two forces are acting on the iceberg. Okay. So we didn't calculate actually the weight. We calculated the upthrust because information were there. As soon as I see density of seawater, I know they have not given density of the iceberg, isn't it? So I can't find the weight of iceberg directly. Indirectly, I can find it by finding the upthrust and equating them because it is floating. This is the condition of floating. Right. Now we'll move on to the next one. An identical block of ice floats in water of a lower density than seawater in air. Floats in a water of a lower density. Can you remember the ship question that we did in Dude? Same thing, isn't it? So, a larger volume of this block is below the surface of the water. Explain why. So, what is the reason, children? I hope you can remember. Weight of the ice block is equal to upthrust, isn't it? At equilibrium. Right? Then what can we say? The weight of the iceberg remains constant. Therefore, upthrust also remains constant. Upthrust is equal to what? Volume of the displaced fluid, density of the displaced fluid, and G. Then we can say what? Since density of the fluid is lower, volume of the displaced fluid would be greater. That is our conclusion. I hope you can remember that what if the not an identical block? What if a heavy block of ice? What is the story then? Then we are going to say weight becomes greater, upthrust becomes greater, V rho G, if it is the same fluid, rho fluid remains the same, G remains the same, volume of displaced fluid must increase. Volume of displaced fluid is equal to volume of the object inside the fluid. Therefore, more section of the object will be inside the fluid. That is the other story that we discussed. Right. Now we are moving on to the 21st question. The 21st question, a grain of sand quickly reaches terminal velocity when it falls into water. State why grain of sand reaches terminal velocity. State why grain of sand, state why the grain of sand reaches terminal velocity. Falling, falling. As soon as I see falling, I'll write the forces of thrust, drag, weight. Terminal velocity, in the sense, what are you going to say? Upthrust plus drag force equals weight, isn't it? Therefore, resultant force will be equal to 0. Then the next thing what they say is, the spherical grain of sand has a weight of this. The grain of sand displaces water with a weight of this. That is indirectly they are telling you. This is directly they are telling W. Terminal velocity of the grain of sand as it falls through the water is this. They are giving us a terminal velocity. I feel like something going to viscous drag. Reduce whether the Stokes law applies to the grain of sand as it falls at terminal velocity. Now what you have to do is, first of all, using these two, we will try to figure out what should be the viscous drag. Can find, isn't it? Upthrust plus viscous drag. Always remember to check which direction it is moving. Falls, falls, down. Upthrust plus viscous drag is equal to weight. Upthrust plus viscous drag equals to weight. Then upthrust is equal to 1.5 into 10 to the power minus 5 plus viscous drag we don't know. Weight is 4.3 into 10 to the power minus 5. So we can figure out the viscous drag. The subtraction of these two, which is 2.8 into 10 to the power minus 5 newtons, children. That is the viscous drag required, isn't it? If it is so, then if it obeys the Stokes law, the viscous drag that we would get for this kind of a terminal velocity would be 6 pi. Viscosity is 1.2 into 10 to the power minus 3 eta r radius, which should be 1.5 into 10 to the power minus 3 divided by 2. I think everybody can understand and would do the same. Read the question carefully, understand the diameter, radius, squaring, all those things day after tomorrow. Multiplied by 6 pi eta r v, v 0.050. Then there you would be getting an answer. Then what can you check? You can check whether this force and this force are equal or not, isn't it? Actually, they are not equal. So, if possible, can somebody calculate and tell me? Then we can say the forces are not equal, therefore does not Stokes law doesn't apply. You can do the calculation and check whether they are correct, okay? And this is not the only way. You can use this force here and write here v and find the velocity that is required to give this force if it obeys the Stokes law. If that velocity and this velocity matches, or we can say obey. Does not match, we can say does not apply. Right. Then this one. Explain how the temperature of the water affects the terminal velocity of grain of sand if Stokes law does apply. As soon as you see the temperature word in a viscosity question, you know what we are talking about, isn't it? When the temperature increases, you can even say the reverse argument, no problem, because they didn't tell what happens to the temperature. Viscosity, don't use the symbols, always use the words, don't use the arrows, use the words. When temperature increases, viscosity of water reduces. According to F equals 6 pi eta RV, to have the same viscous drag force and this one, upthrust, this is the terminal velocity condition. So upthrust remains constant, weight remains constant, viscous drag force should remain constant, isn't it? Temperature increases, viscosity reduces.
Hello, sir.
Yeah?
So normally when we say viscosity reduce, don't we also say that drag goes or reduces?
Uh,
Viscous drag?
Viscous drag at a given velocity reduces. That's true, Kavisha.
Then can't we say for the same weight as viscous drag reduce and then say the velocity increase to keep the same drag?
To keep the same drag, right?
So won't it change actually?
Yeah, actually, Kavisha, now it's like this. Now we'll think of two situations, okay? Let's see. Uh, 20 degree Celsius and 50 degree Celsius. In 20 degree Celsius, a sphere is falling down. Let's think that this is the required terminal velocity is 0.2 meters per second. Because in 20 degrees Celsius, we know that when the temperature is low, viscosity is greater. So still the same sphere, same size. So weight is also the same and upthrust is also the same. In the terminal velocity condition, there will be a viscous drag. So it would make this equation to be valid. That is okay, isn't it, Kavisha? Then what if we increase the temperature for the similar sphere and if it is traveling at 0.2 meters per second? Then what will happen is, as the terminal velocity is lesser, now we have an up weight, we have an upthrust, as the terminal velocity, as the velocity is 0.2, but viscosity is now low for a given velocity, viscous drag would be less. We would have a lesser viscous drag. Then, Kavishan, the problem is it enough to reach terminal velocity? Not enough, isn't it? Then what will happen? Is this the balance condition? No. Then, as it is still under downward unbalanced force, this sphere will accelerate. Then this sphere will reach a greater terminal velocity, somewhat like 0.7 meters per second, let's say. Then this viscous drag is also increasing, and ultimately that will become equal to weight and upthrust difference. So that's what I told. Since upthrust and weight remains constant, viscous drag force also must remain constant for the condition of what? Terminal velocity. So since to have the same viscous drag force in a lower viscous object or lower viscous fluid, the terminal velocity should be greater. Still have the doubt too? Is it okay, Kavish?
No, sir, it's okay now.
Sure, right?
Yeah.
Okay,
Okay, thank you.
that is the idea, right? Then we'll move on to the 22nd question. A simple hydrometer is a cylinder, mass at one end. The cylinder floats vertically in a liquid. A student places hydrometer in a sample of pure water. Complete the free body force diagram below to show the forces acting on the hydrometer when floating at equilibrium. We know when it is floating, it's not moving. Therefore, there can't be any drag forces, isn't it? Only two forces that are acting would be one is the upthrust and one is the down force. They should be acting along the same line, opposite in direction, equal in magnitude. But remember, they are not third law pair because their types are different and they're acting on the same body. So this should be labeled as upthrust. This should be labeled as weight. Then the next thing, the student placed the hydrometer in a sample of seawater. The seawater is more dense than pure water. The seawater is more dense than pure water. Now I think you all know where we are heading, isn't it? Same idea. So these are back-to-back past paper questions, isn't it? So what is the next thing that can ask? Wait. If they ask, otherwise they can ask the same question. So What are we going to say? Explain why the vertical position of hydrometer was higher in seawater than in pure water. We can say what? As the hydrometer is floating, weight of the hydrometer should be equal to upthrust. Isn't it the same thing that we told earlier? Weight is constant, upthrust should remain constant, isn't it? Then upthrust is equal to volume of the displaced fluid, rho fluid G. Density of the fluid is lower, so volume of the displaced fluid would be greater, isn't it? Then we can say what? Volume of the displaced fluid is equal to volume of the object or hydrometer inside the fluid. Then in this case, that's what we argued. In this case, we'll see what happens. We can go for a reverse argument or forward. Explain why the vertical position of hydrometer was higher in the seawater. Right. So what are we going to say? They say that dense than pure. So again, same mark points, we can say upthrust equals weight of the object. Upthrust is equal to weight of the displaced fluid, which is equal to volume of the displaced fluid, density of fluid, and gravitational field strength. Density of seawater is greater, so volume of the displaced fluid in seawater needs to be lower, isn't it, to have the same upthrust, right? Then we can say what? Volume of the displaced fluid is equal to volume of the hydrometer inside the seawater. Therefore, less portion of the hydrometer will be inside the fluid. That is right. Then the second part of the question, part B, calculate the change in vertical position of the hydrometer when moved from pure water into seawater. Change in vertical position. It's a 5-mark question. A lot of calculations are there, isn't it? So calculate the change in vertical position of the hydrometer when moved from pure water to seawater. So upthrust equals weight. Upthrust equals weight. We have no other option, isn't it? Upthrust. Cross-sectional area, volume of the displaced fluid, density of the fluid, and G, it's equal to weight. Volume of the displaced fluid, density of the displaced fluid, G, should be equal to weight. You can see still the weight is same, isn't it? Now I'm just telling you one method. This is not the only method. Volume of the displaced fluid is equal to volume of the hydrometer inside the fluid. This is normal. This is C. However, weight didn't change. Then we can equate them if you like. What is volume of the displaced fluid? Cross-sectional area of the hydrometer multiplied by height of the hydrometer inside the fluid. Density of the pure water. Cross-sectional area of the hydrometer, height of the hydrometer in the fluid, in the pure water, in here in the seawater, density of the seawater, G. From this, I would be getting one answer. Area cancels off, G cancels off. Height of the pure water, which we can find when we multiply it by density of pure water and divide by density of salt water, we will be getting height of salt water. Just okay, right? But the thing is, you know what is height. So as the weight of hydrometer is given, We will use one equation. Volume of displaced fluid, we don't know. X they have given. Cylinder with mass. That means they have given us the diameter. So volume of the displaced fluid, cross-sectional area, pi, diameter, 1.23 divided by 2. So it becomes the radius. Pi r. Oh, unit conversion is also necessary. Right by 10 to the power minus 2 square, pi r squared, h in pure water. Density of pure water 997, 9.81 is equal to weight of hydrometer 0.324. So height in the pure water can be calculated 0.324 divided by this pi and 1.23, 10 to the power minus 2 divided by 2 squared, 997, 9.81. You will be getting an answer which is equal to 0.2786 meters. If you like, you can do the same thing. Then no need of all this hard work, okay? If you like, you can do the same thing here and you can find what? Height. This also would not change. Height of salt water will be equal to weight 0.324. Cross-sectional area doesn't change. Pi 1.23, 10 to the power minus 2 over 2 squared. Only thing changes density of seawater, 1025, 9.8. That would give us 0.2710. Then this is not needed, okay? Then we can get what? The height difference. This minus this. Then that is fine. Then we'll move on to the next one. A small remotely controlled, now we met two situations about the floating condition. I hope you would get a easy question like this. A small remotely controlled submarine is used to explore the sea. The engine of the submarine produced a horizontal force of 70 Newton. The drag force on the submarine was 43 Newton at an angle of 25 degrees to the horizontal as shown. Determine the resultant force of these two forces on the submarine by drawing a scaled vector diagram in the space below. So we will draw one vector, 7 centimeter, let's say. At the end, now you know I have to draw this one. At the end, I have to draw this one. So then when we draw a sketch on the given diagram, we can easily identify that this is 25. So I will measure from here. This is the place where many students go wrong. At the end, keep the protractor, 0 here, measure 25 and mark. How many centimeters? 4.3 centimeters. Then join this and this. Measure the length. You would get the resultant. Angle of resultant from horizontal, force to the horizontal, force to the horizontal. So you can either measure this angle or you can either measure this angle, doesn't matter. Right. Then this one. This question, it's another star mark, 6-mark question. This was similar to the question that was there in the tute. appeared in 2025 January paper. The TUT question was taken from, I think, 2018, 2017, or 2019 WPHO1 paper. So, having a good idea about those questions also better. Then, before, as we are like almost closing, we are almost like at the very end. Only 7 more questions, not 7, 6 more questions. I discussed these questions. Please send me a message, those who were present. I'll share this recording with you all. Then you do these things alone and check whether you can argue, whether you are getting stuck. Because if you are, as long as you are not getting stuck, then we are 100% sure that in the exam also you won't get stuck when you see a question. Right. A crane on the ship can lift the submarine out of the sea as shown. They are asking, as it is a 6-mark question, the submarine is initially completely underwater. And rest just below the surface. A cable from the crane is attached to the submarine, so the cable is vertical. That means there are 3 forces: weight, upthrust, tension. However, they are balanced. Okay. The crane pulls the cable, the submarine moves vertically upward at a constant speed. I jumped in before I read this question. Because of this constant speed only, we have to say that it's balanced. Explain how the tension in the cable changes as the submarine moves from below the surface of the water, being completely out of the water. So the only thing that we have to be careful when explaining is this part: weight, tension, upthrust. Weight and tension not. Explain how the tension in the cable changes. Okay, how the tension in the cable changes. So we have to understand that as the submarine moves with constant speed, resultant force acting on the submarine will be equal to 0. Therefore, when the submarine is inside water, tension plus upthrust must be equal to weight. Hence, tension equal weight plus minus upthrust. Done. When submarine, you can even draw a diagram, is at B or leaves the water, while it is leaving the surface of the water, we can say, like as in B, since tension is equal to weight minus upthrust, the upthrust reduces because weight of the displaced fluid reduces. Hence, now this is subtraction. Now let's say this is 5 and this is 15 and this is 10. At that moment, tension would be 5, isn't it? Now upthrust is reducing, so it becomes 5. So the tension became what? 10. Hence, tension will become equal to 10. Hence, tension will increase. Hence, tension will increase. Then finally, when the submarine is fully outside the water, tension will become equal to what? Upthrust. Sorry, not upthrust, tension will become equal to weight of the submarine. So similar question, yes. So there also we were thinking individual things, isn't it? Earlier also the same thing, right? Now we'll move on to the 24th question, where we have state the condition for Stokes law to apply. You can remember small smooth sphere falling slowly through fluid, where flow of fluid around the sphere should be laminar. Isn't it? Smooth sphere falling slowly through a fluid, because there should be a laminar flow around the sphere. Then we have deduced whether Stokes law apply as the mass fell through water. Again, a similar question, isn't it? So we'll see. So we will go with the same order, isn't it? Terminal velocity, mass fell 25 meters in a time of this. Why do they give distance and time to find the terminal velocity? Distance divided by time. Which is there was a difference of 4.6 Newton between the weight of mass and upthrust on the mass. Here to the bottom of the sea. Mass accelerated to terminal velocity as it fell. Okay, falling. I want to know whether it is falling or rising up. Upthrust is there. Viscous drag is also there. Weight equal upthrust plus viscous drag. Weight minus upthrust is equal to viscous drag. There was a difference of 4.6 between weight of the mass and upthrust. So 4.6 is viscous drag. That's what they say, isn't it? Then that is according to the calculation. The spherical mass has a volume of this much. Deduce with the Stokes law apply. So then we will find, according to the Stokes law, what is the viscous drag? 6 pi eta 1.2 10 to the power minus 3 r. There's a problem. V, there is no problem, 69.4. Now r they have not given, instead they have given the volume. 4 over 3 pi r cube equal 45. So from there you will be able to calculate the r value, multiply 45 by 3, divide by 4, divide by pi, and take the cube root, 0.0221 centimeter. Actually we are getting 2.21 centimeters. So it would be 0.0221 meters. Then from this, we will be getting a viscous drag force which is equal to 0.0347 newtons. Then compare like earlier. Now, I think you are getting the idea. When we do these three past papers together, you will feel like similarities, isn't it? So better tomorrow, take 2023, three papers, and do like this. Do all the motions together, forces together, likewise. I think good experience for you. Then here you can compare 0.0347 is less than 4.6 Newton, therefore Stokes law doesn't apply. Then this question, part B. Some similar questions are there, some different questions are also there. Graph shows how the vertical velocity v of the driver varied during a drive. How vertical velocity v of the driver varied during the drive, during a dive, not driver, diver, varied during a dive. Vertical velocity v of a diver varied during a dive. Okay. Initially, the velocity is negative, becomes terminal, velocity becomes positive. That means velocity is increasing, again becomes terminal. The diver was at the surface of sea at 0 seconds. Explain how the graph could be used to show that diver reached the surface of the sea again at 82 seconds. Okay. Explain how the graph could be used to show that diver reached the surface of the sea again. Oh, good. Can you see that it's about displacement being 0? It's not calculation, it's explanation. You can see that this is a negative displacement. This is a positive displacement. At here, if the diver is on the surface of that thing, at here also the diver will be at the same place if the displacements are equal, so they would get cancelled off, isn't it? So what can we say? Area between the line and the time axis, so you can say x-axis, gives displacement. That is number 1, we can say. From 0 to 30 seconds, let's say, or 25 seconds, let's say. I can't say 25 because there's a part above it. So we say, I can't say 30, let's say 25. From 0 to 25 seconds, the graph shows the diver's displacement below the sea level. From 25 to 82 seconds, the graph shows the diver's displacement. Actually, it's 31, going up, going down. From 35 to 82 seconds, the graph shows the diver's vertically upward displacement. So this represents that the diver is going down. This represents that the diver is again coming up. If the area of the two graphs and the x-axis is equal, the total displacement will be 0. Therefore, the diver will be at the surface. Again, I'll tell. In a velocity time graph, area under the graph and the x-axis gives displacement. 0 to 25 seconds, displacement is negative. From 35 to 82 seconds, displacement is positive. As these areas are equal in magnitude, the total displacement would be 0. Hence, the diver has reached the starting position. Determine the vertical acceleration of the diver at 70 seconds. Velocity time graph acceleration is asked, it's a gradient. So what you have to do is what? Keep the ruler here, draw a tangent, y difference divided by x difference. You would get in here, however, as it is negative, don't try to forcibly make it positive, okay? x2, y2, x1, y1. Use the same order, y2 minus y1 equal x2 minus x1. Right. Then 25th question. Explain. The student released a spear from rest in the oil. A student determined the terminal velocity of metal spear falling through a container of oil. A student determined terminal velocity of metal spear falling through a container of oil. The student released the spear from rest in the oil. Explain why spear reached terminal velocity. That story. Parachute story from small IGCAC days. Weight is greater than the upthrust plus viscous drag. Therefore, the spear accelerates due to the downward resultant force, which is equal to weight minus upthrust plus viscous drag. The speed of the spear increases according to F equals 6 pi eta RV. Viscous drag force increases. Therefore, the resultant force decreases. Acceleration decreases. When weight equals upthrust plus viscous drag, resultant force will become equal to 0. Therefore, resultant force will become equal to 0. Therefore, the object reaches, spear reaches terminal velocity. That is the idea. Right, then we'll move on to the next question. Right, then we'll move on to the next question. That is, the student measured the time taken for the spear to fall through 0.45 meters of oil at terminal velocity. Calculate the viscous drag force on the spear. Right. Again, they have given us the distance. Viscous drag force. Asking F. Assume conditions for Stokes law applied. Time is given. So what can we say? We can say we can find the terminal velocity. Then use F equals 6 pi eta RV. No issue, isn't it? What do we find? Distance 0.45 divided by 7.3. Then 6 pi eta is given. R is given. We have calculated. You get the viscous drag. Then they are telling the student repeated the experiment using second spear with a greater diameter. Then we say the density of the second spear was the same as density of the original spear. Okay. The student repeated the experiment using a second spear with a greater diameter. So smaller diameter, greater diameter. Density of second spear was the same as density of the original spear, right? Then the next thing is explain how the time taken for the second spear to fall through 0.45 meters at terminal velocity compares with the time taken for the original spear, right? Both are falling down. They both are falling down at a terminal velocity. So we can say, explain how the time taken for the second sphere to fall through 0.45 meters at terminal. They are asking the same question in a different way at terminal velocity. So now that means they have both reached the terminal velocity. It's just a matter of, now let's say both are traveling the same speed, the same terminal velocity, not same speed, same terminal velocity, 0.45 meters. We have to figure out whether they both have the same terminal velocity or different terminal velocities, isn't it? That's the thing. Now we'll see. Now, again, that hammer and feather questions, all those things can be taken into account. So we will see if the radius of the second sphere is greater, weight is equal to 4/3 pi r squared, r volume, density of the object, gravitational field strength. When the radius of the second sphere is greater, weight of the second sphere would be greater. That is the first thing that I can see. At terminal velocity, we all know that weight is equal to upthrust plus viscous drag. Remember, children, we did three or more questions falling down. If they give you a question about moving up, don't take upthrust plus viscous drag. Moving up in the sense, what is the only thing? Upthrust, weight and viscous drag will be down, okay? Then upthrust equals weight along with the viscous drag. That is idea. Then just a small red alert. At terminal velocity, this is there. Then we can say what? Since the weight of the object is greater, we can't only consider about weight. Upthrust is also there, isn't it? We see upthrust 4/3 pi r cube, density of fluid, and g. Upthrust is also greater. Okay. Then there is a issue. So, only thing that we have to consider here is what then? F is equal to 6 pi eta rv. Viscous drag will be equal to weight minus upthrust. So, now think like, I'll take a numerical example and explain. Earlier weight is 10, upthrust is 5. Let's think like that. So answer would be 5. What if I double the radius? It would affect the upthrust in what way? It would be increased by 8 times. Weight also will be increased by 8 times. Why? 2 to the power 3 is 8. So this would become 80. This would become 40. So there, what will happen to the viscous drag? Will increase. That's the best way to tell you what is happening here. Otherwise, it would have been very hard for me to explain. So now you understood that when the radius is increasing, both upthrust and weight will increase. isn't it? Then according to F equals 6 pi eta RV, according to F equals 6 pi eta RV, as the required drag force is greater, why weight and upthrust increases by greater factor than the drag force. So the required drag force is greater. Therefore, the object would reach a greater terminal velocity. Now, the terminal velocity of the bigger sphere is greater, isn't it? So what will happen to the time it would take? Less time. Therefore, it would take a less time. Again, I'll tell. Since the diameter is greater, both upthrust and upthrust and weight of the object will increase by a greater factor than the drag. Why did I use the word greater factor than drag? Because the diameter being greater, let's say I said that if the radius doubles, upthrust becomes 8 times. Weight becomes 8 times, but viscous drag only becomes 2 times. Isn't it? So this only becomes 2 times. So we need to increase it more to make it 40. So from where do we get it? By increasing the terminal velocity. So we can say that when the diameter of the sphere increases, weight and upthrust increases by a greater factor than the drag force. And when the radius increases, the drag force also increases. Hence, the sphere should have a greater velocity, terminal velocity, than the smaller sphere. So it would take less time to travel 0.45 meters. Right. Then the next question. Student has a spring. Now we are moving on to solids. So quickly I can move and finish. Still, I think I really have to thank you for staying until this time. But the thing is, if I had turned this into tomorrow, then your time I'm taking. Today I took the time that however you will be tired and all. So I think this would have been productive because you can use this knowledge when you're studying or doing the papers tomorrow. Right. We'll see the solids, last part. Delta F equals K delta X. That is nothing. Force is given, K is given, and delta X has to be found. So very simple. They are not asking the extension, they are asking the new length. So always read the question carefully. You would get an extension which is equal to 0.28 meters. So the new length will be equal to original length plus the extension. If it is a compression, it would have been original length minus the compression. So it would be 0.18 plus 0.28. Now I'll move on to the next one. 27th question. Only one more question, two more questions. This is a star mark 6 mark question. The student measured the diameter of the copper wire. The student clamped one end of the copper wire to the bench. The wire passed over a pulley and masses were added to the other end of the wire. Meter rule was fixed to the bench and fixed to the wire as shown. Please there. The student measured the diameter of the copper wire. Describe the other measurements that need to be made using this apparatus and how they will be used to determine the Young modulus of copper. You should define the meaning of any symbol you use. Right. Describe the other measurements that you need to be made this apparatus and how they will be used to determine the Young modulus of copper. You should define the meaning of any symbols you use. Right, that is the idea. Then we will see. Young modulus. Now we'll plan. Young modulus comes from stress over strain. Stress, force over area, strain, extension over original length. Area is not a measurement, it comes from pi diameter divided by 2 squared. Extension is not a measurement, it comes from new length minus original length. Original length is a measurement. Force is not a measurement, it comes from mg, where mass is not a measurement, it comes from balance. Now we say, now we'll plan, doesn't it? Measure the original length using a meter rule, L naught. And it's easy for us to use it in the future if we need. Then measure the new position of the marker, isn't it? Measure the new position of the marker and calculate the extension by new length minus original length. This is fully done. Measure the masses hanging using a top band balance and use W equal mg to calculate the force acting on the wire. So this part is also done. See how easy the things are. This is also I told over here. Then we are left with what? We are left with this part. What is that? That is cross-sectional area. So we are going to say, measure the diameter using a rattling additional operations. Measure the diameter using a micrometer screw gauge and use pi d over 2 squared. Measure diameter d using a micrometer screw gauge at different positions and different orientations and calculate the mean diameter and use pi d over 2 squared to calculate the area. This is also done. Now we came up to here. Then we have to say what? Now we are going to go for Young modulus, isn't it? For 6 different forces, calculate the extension. Calculate the stress using force over area. Calculate the strain using extension over original length. Plot a graph of stress against strain. Young modulus equals gradient. So what I try to teach you is the plan, which I taught you several times. So again, I repeated, I only forgot one thing. For the same force, repeat the experiment and measure the mean extension. You can say repeat all the measurements and calculate the mean values. So that's the idea. Then they are telling the next part, that is another student attached weight of 5 Newton to a copper wire, diameter is this, calculate the extension of the wire, length of the wire, Young modulus is given. So easiest way is Young modulus is equal to what? Stress over strain, that is force over area, extension over original length. So Young modulus given, length of the wire given, weight given, cross-sectional area, diameter pi d over 2 squared, unit conversion is there, be careful, given, Extension is the only thing that is not known. Straightforward. Substitute, get the answer. Then 28th question. The original length of a sample was 36.8 meters. Original length of the sample was 38.6. This is another question. Tugboat is a small boat that can be used to pull large ships. A tugboat is attached to a ship using a thick rope. Sample of rope is tested to make sure that the rope will not break when a ship is pulled. The original length of the sample, that is XO, you can say X naught or L naught. Calculate the strain. When the length of the sample increased 2, so strain is equal to extension over original length, isn't it? So how do you calculate the extension difference? Divide by original length, you would get the strain. 38.1 minus 36.8 divided by 36.8. Then they have given us a stress against strain graph, which is not a straight line passing through the origin. Is it so? It's kind of like a straight line passing through the origin, isn't it? You can keep a ruler and check whether if it is so, it always looks slow. The diameter of the sample is 220 millimeters. Determine force applied to the sample when the strain was 0.025. 0.025, that is over here. So we can get the stress value, which is over here. 10 square shows 50, 1 square shows 5, 110. That is in megapascals. Be very careful. Into 10 to the power kilomega 36. Strain doesn't have a unit, so no issue. Strain value will be equal to what? 0.025. Then we have to determine what force applied to the sample when the strain versus this stress is equal to force over area. Force we figured out, no, stress we figured out, 110, 10 to the power 6. Force. Area we can find, isn't it? Pi, diameter, 220 into 10 to the power minus 3 divided by 2 squared. So you'll be getting an answer for that. Explain how the area under the stress strain graph and the volume of the sample can be used to determine energy stored. Can you remember I told area under the graph of stress strain and the strain axis actually gives us what? Energy density. So we will try to show that, isn't it? Then we will start from what we learned from the theory. Area under the graph, it's equal to what? Energy stored per unit volume. Isn't it? So can you remember I told the area can be checked by the product of the y-axis and the x-axis. Stress, strain is equal to force over area and extension over original length. That would be equal to what? AX cross-sectional area, that is force into extension would give us energy, and cross-sectional area into X would give us volume. That's how this came. Therefore, this is area, energy divided by volume. Then area multiplied by volume. It's equal to what? Energy. So we got our proof. Then we reach the last question for the day. We did 3 papers. Some spiders from silk in long, thin thread catch flying insects. The Darwin's bark spider can produce a very long threads. A scientist investigated the properties of these threads. The scientist applied force to stretch threads to spider silk. The stress in one thread was 4.3 megapascals. The radius of the thread was 1.9 into 10 to the power minus 6 meters. Calculate the force applied to the thread. Stress is given, radius is given. So now as soon as you are being asked, you should remember stress is equal to what? So area. 4.3 as usual, they are giving you a unit conversion. Force by 1.9 into 10 to the power minus 6. If we plan to divide it by 2, we go wrong because this time they gave us the radius, isn't it? So from this, we can calculate the force. Then when we read this part B question, children, the scientist investigated a thread of length 25 meters, determined the length of this thread when stretched to its limit of proportionality. Stress at the limit of proportionality is given. Young modulus is also given. Young modulus is equal to what? Stress over strain, isn't it? Then young modulus, let's say 8.7 kilomega giga 10 to the power 369. Stress 300 kilomega 10 to the power 6 divided by strain extension over original length. Original length is what? 25. Nothing for 4 marks, isn't it? Extension will be equal to then 300, 10 to the power 6, 25, 8.7, 10 to the power 9. So we will be getting 0.862 meters. But they want what? Determine the length of this thread. So we met similar questions, right? So length, what should we do? Is it a compression or an extension? It's an extension. So we'll add 25 plus this 25.862 meters. Part C. The table shows some properties of spider silk and type of steel. Spider silk is given, steel is given. The sketch graph shows a stress-strain relationship for a spider silk up to the limit of proportionality. Add a line to sketch the graph to show the stress-strain relationship for the steel up to limit of proportionality. So you see the stress-strain graph, Young modulus is given by what? Gradient, isn't it? Therefore, steel has very long, big gradient. Stress at limit of proportionality. So we have to understand that this is 300, isn't it? So this steel graph should have a bigger gradient, but should not stop before 300. We have to finish the straight line above 300. 1 mark for gradient being bigger, 1 mark for going above 300 mark. So this is 350. If you wish, you can mark. A sample of steel has the same shape, length, and cross-sectional area. Think you can remember? Stiffness depends on the object. Young modulus depends on the material. Then they are asking, each sample is stretched to its limit of proportionality. Explain which sample has a greater elastic strain energy. A sample of steel has the same shape, length, and cross-sectional area as a sample of spider silk. Stretched to its limit of proportionality. Actually, it is given by area under the graph, isn't it? Elastic strain energy density is given by that. So, we can say here, elastic strain energy is, we can't say it's equal to the area under the graph, so we will say it's directly proportional to. If it is a force against extension graph, we would have told that what elastic strain energy is equal to in an area under the graph. But in here, as it is stress against strain, we know area under the graph gives what? Energy density, energy per unit volume. So we will say like this. Elastic strain energy is directly proportional to area under the graph of stress against strain. That is number one. Area under the graph spider silk is greater than area under the graph for steel. So elastic strain energy for spider silk is greater than elastic strain energy of steel. After a long day, we did a 250 mark paper, 15 mark paper. Good luck. Study well. Do more papers. If possible, do like what I did today. Take 2023 sets also. Convert them into the chapter wise and do accordingly. I hope the paper would be easy. Write answers carefully. Grade boundaries would be a little bit high, so try your level best to score as much as possible. Good luck. Good night.